more Arabic flavored music. Alright, music has so much to do with mathematics. What I'm doing is I'm improvising over a scale that's known as the Phrygian dominant mode. So there's sort of a certain selection of notes that give it that flavor. Very mathematical. Don't forget that. Alright, so what we're going to look at in the very last part of this is what we call Hurons Formula. This has been around as long as Huron's been around, and the thing is, this is how you find an area of a triangle if you know all three of the sides, regardless of whether it's a right or oblique triangle. It doesn't matter. So this is Heron's formula. There's basically two parts to it. There's the part that's called the semi-perimeter. The semi-perimeter just means that you take the perimeter, which just means add up all the sides and take half of it. And then the area comes from this formula, and I'll give you some examples and show you how that goes. Heron is actually a pretty interesting person to read up a little bit about. So he's a Greek mathematician, an incredible inventor, they say. So, I mean, he's responsible, if I'm remembering right, he came up with a vending machine in ancient Greek. Okay, and I think if I remember right, maybe they vended water or something. Okay, it wasn't Coca-Cola. I think it was water. So he's the one who did that and made the catapult. I think he invented all kinds of things. So he's considered to be the greatest experimenter of antiquity. All right, handsome guy. All right, so let's see. Going down here, we're going to do an area of a triangle. We've got all three sides on here. So what we do with Heron's formula, the first thing you do is S is called the semi-perimeter. The semi-perimeter just means to find the perimeter of the triangle, which of course just means add up all the sides and then take half of that. Hence, that's why we call it the semi-perimeter. So I'm going to do that just basically on the calculator and get that put together. So let's see, let's go ahead and find the perimeter. So the perimeter is 1.9 plus 2.6 plus 4.3, and that will be the perimeter. And then I just take half of that. So the semi-perimeter is going to be 4.4, and that's half of the problem, is just getting that thing that we call the semi-perimeter. Okay, that's where you begin when you're working out this problem. Okay, now Heron's formula goes like this. The second thing is the area is the square root. It's kind of a long formula. You do the semi-perimeter, and then you take the difference of the semi-perimeter and each side. So that's how Heron's formula goes, is like that. And you can pretty well just learn to do this in 1 or 2 steps on the calculator. All right, so when you put this together, the semi-perimeter goes here. That goes in several places in your formula. So it goes like this. You'll do the square root of the semi-perimeter, 4.4. Then you do the 4.4 minus one of the sides. It doesn't matter which side's which, so I'm going to do 1.9. Then I'm going to do the semi-perimeter minus another side, which is 2.6. And then finally, I do the semi-perimeter, 4.4 minus the other side, 4.3. Now, you can put that all in one step on your calculator if you want to, which is what I'm going to do on this problem. So I'm just going to do the square root. And then under that radical, you'll have 4.4. And you might as well just let the computer crunch it all out. So 4.4 minus 1.9. Be sure you close parentheses in each part. And then you do 4.4, subtract the other side, 2.6. And then finally you do the semi-perimeter, 4.4, minus the last side, 4.3. The semi-perimeter should always be bigger than each of those individual sides. So then you do that square root. And then that will give the area of that triangle. So that is approximately, I'm going to say, 1.41 units squared would be the answer of that. Okay, so again, what I've done is I've just done the semi-perimeter, adding up the sides, dividing by 2 to get 4.4, then tack it directly into Heron's formula like that. Okay, if you want to, you can also do this like this. You can do the 4.4 and the 4.4 minus 1.9 before you do the square root. So I've got 4.4 minus 2.6, and then close off by doing the 4.4 minus the 4.3. Just get that answer, and then you can do the square root of that. So ultimately what you were doing on this problem is you were doing the square root of 1.98. Okay, so you can do that, use the A and S key if you want to, like that. Okay, so that's how you do Heron's formula to find the area. All right, if you're interested, the derivation of this is kind of interesting, so it's worth looking up and Googling and doing a little bit of research on to see how this formula was derived. Okay, on the next page, I'm going to do something that I think is kind of interesting. We're going to use our area formulas that we've learned, Heron's formula and the side angle side formula, to look at how we could figure out the area of this pentagon. Now, this is a regular pentagon, which means all of the sides are equal. So basically, in this particular problem, all of these sides are 4.5 feet because it's a regular pentagon. That also means that all of these angles are also equal, and that's a geometric theorem. You have a regular polygon, then all of the interior angles are always going to be equal. So let me show you kind of something that I think is kind of interesting over on the side here. So one thing that we know is we know if we have a triangle, then the measure of A, B, and C adds up to 180 degrees. So we've been using that all along. Well, if you go on to a four-sided figure, and it doesn't matter what the four-sided figure is or what it looks like, you can make that into two triangles. So what that means is this triangle, the angles add up to 180. In this triangle, the angles add up to 180. So if you had A, B, C, D, then we would know that the four angles in this quadrilateral are going to add up to 360 degrees. So it's kind of interesting on this. Oh, I think my cat's going crazy and getting in a cat fight. Stop it. Yeah, well, just let him be. My territorial cat. All right, so let's see. Now, if we go to a pentagon, here's how a pentagon works. Okay, and it doesn't matter if it's regular or not. The idea is you've got three triangles. So basically, each triangle, its angles add up to 180. So it would mean if you had 5 angles now, A, B, C, D, E, then A plus B plus C plus D plus E would be equal to 360 plus another 180. Okay, so that would end up being 540 degrees. Okay, so that's what we know in this pentagon, is that the angles add up to 540. So the first thing I'm going to do is I'm going to figure out these angles. So each angle is just going to be found by taking 540 degrees and dividing by the 5 angles that we have. So it's a regular figure. All of the angles are the same. So 540 divided by 5, I think it's 108. So that is 108 degrees is what we know then. Okay. All right, now I'm going to sort of fill this in as I go. We know all the sides were given, and now we know that every angle is 108. And then we're going to figure out a way to use the formulas we've learned in order to put this together. Okay? Well, my thought on this is to do this way. All right, what I'm going to do is I'm going to divide this up into 3 triangles. Okay, like that. And then we can do some pretty simple calculations to get this area put together then. So I'm going to call this region 1, region 2, or let's call it T for triangle. Let's call this triangle 1, triangle 2, and triangle 3. Okay? So what I can do on this now is it's actually pretty easy to find the area of these triangles. Okay, so I'm going to look at this region here. I'm going to look at that triangle, and I'm going to look at that. Now, those are equal areas because they have equal sides and equal angles. So really, we've already learned how to do this. So the area of triangle 1 is just going to be, remember the formula goes like this. It's 1/2 the product of the bases, which or of the sides, 4.5, times 4.5, times the sine of the angle in between. So that is the side angle side formula that we learned in a previous section. So we have basically this. We have side angle side of a triangle, so you can crunch out that formula then. And I'm going to do that in just on my calculator and maybe round that off to a couple of decimals or something. Okay, so if I do that, I'm just going to put in like this. I'll put in 0.5 times 4.5 times 4.5 and times the sine of 108 degrees. Okay, so we have this. Let's just round that to 9.63, and this is in feet, so that's square feet. Okay, now also the area of triangle 2 is going to be the same because they're equal. Okay, those two triangles are congruent because of side angle side. In geometry, you learn about triangle congruence. If both triangles share a side angle side, then the triangles are the same. So they're going to have the same area. So that's what we have. So that leaves us with figuring out how to do this then. Okay, well, the third thing I'm going to do is I'm going to find this side right here. I'm just going to call this side like x. Okay, like this. Now, we could use law of cosines to do this. Okay, so that means law of cosines, what we'd have to do is we'd have to do this. Again, we have a side angle side, so we would have x squared equals the sum of the squares of the other two sides. So that would be 4.5 squared plus 4.5 squared minus twice the product of those two sides, okay, times the cosine of the angle in between those. Okay, so that's applying law of cosines. So I'm going to crunch this out on the calculator also. So I just put in 4.5 to the second plus 4.5 to the second, and then minus twice the product of the sides, 4.5 and 4.5, and then the cosine of the angle in between, and that'll give that value like there then. Okay. Oh, did I put something in? I put something in there wrong. Crap. Got to be so careful when you put this stuff in. So I got 4.5 to the second. Lucky I caught that too. Plus 4.5 to the second. Okay, that gives that. And then minus twice the product, 4.5 times 4.5. And then the cosine of 108. So hopefully I got this put in here correctly now. All right. So that will give me about 53.01518827. I'm going to do all my rounding at the end of this. So let's go ahead and do this. Maybe round this off to maybe 2 decimals. Just kind of a personal decision. So I'm going to go second square root. Again, use the ANS key the way I've shown you. And then that side is going to be about 7.28 feet. Okay, so that means we got this side right here is 7.28, and so would that side. Okay, there you would get the same thing if you did law of cosines again. It'd be the same problem essentially. Okay, all right. So now what we need to do is, if we're going to find the area of this triangle, well, we can use Heron's formula to finish this up then, see. So see, we know all the sides. The sides basically are 7.28, 7.28, and 4.5. So if you look at the triangle that I'm looking at, is we have what we would call an isosceles triangle, and we could use Heron's formula to figure this out then. Okay, so let's do that. So when we do Heron's formula, we'll work out the semi-perimeter first of all. So now we're doing Heron. And with this one, the semi-perimeter, again, we add up the sides, 7.28 plus 7.28 plus 4.5. Take half of that perimeter, and I'll just do that all on the calculator. All right. So let's see, with this, I'm going to just do 7.28 plus 7.28, and then plus the 4.5. Now you can do this without writing anything on your paper. That's the perimeter when we add those up. And then if I divide by 2, that'll give the semi-perimeter. So that's about 9.53 feet then. Okay. Then I'm ready to go to Heron's formula. So Heron's formula, the area is going to be, we got this big square root, so we have semi-perimeter, and then the semi-perimeter minus each side. So the sides are 7.28, another 7.28, and finally 9.53 minus that given side of 4.5. Okay, so I'm going to put that in the calculator, and then that'll give the area of triangle 3. All right. Okay, so let's put this in then. I'm going to do this like this, 9.53, and then I'm just to be safe, because sometimes you can't see what you're typing on this. So 9.53 minus 7.28. Okay, then you got to do that again, so I could actually double that if I wanted to. So I could have just done this. Actually, we could do this instead. Okay, because we have 2 of those products right there. And then I can go times, and I got to do parentheses, 9.53, and then minus 4.5. All right, and then that'll give this, and then we'll be ready to do the square root of that. So we're going to do the square root of 165.858214, and then that will give the area of triangle 3. So I'm going to use my A&S key. Okay, and that gives an area, I'll use 2 decimals, 12.88 square feet. Okay, so here's kind of what we have in here. We end up having these 3 areas, so then all we got to do is add them up, and then we got the answer to the problem. So the final answer, I'm just going to say area total is just going to be 9.63 plus 9.63 plus 12.88. Use my calculator, that'll give the final answer of that problem then. Okay, so 9.63, you can do 9.63 times 2 if you want to, and then add 12.88, and that'll give the total area, which we're going to round as 32.14 square feet. This is a great problem because it puts together so many things. Okay, that is just a beautiful problem. Notice that I used both of the area formulas, Huron's formula, the side angle side formula, and I used law of cosines. What a great problem. All right, okay, so we got that. All right, I think, you could probably find some things online where you could probably check the answer to finding the area of a regular polygon if you wanted to. All right, so pause if you need to write this down and think through this. Otherwise, I'm going to have you move on and do the next 2 problems, and then that'll close the deal on this section. Okay, before I go over the problems, I want to show you a couple things. I made a little mistake on this. That's the reason I was kind of spending a little bit of time looking up a website that can check your answer on this. I'm going to show that to you in just a minute here. So I made a slight mistake right here. When I did this calculation here, okay, this right here, the area of that triangle with Heron's formula, I think I must have just put something wrong in the calculator. That would have given an area right here of 15.58 square feet. Okay, then the final answer on this should have been this. Okay, gosh, it's so hard sometimes for me to see what I'm putting on this calculator. So I got the area should be 34.84 square feet. Now I'm going to show you this website that I went to, and I try to check things as much as I can when I'm making these videos because I don't want to produce something where I've got a mistake in it. So that's the answer. But I'm going to take you to this website that I found, and I'll put this on here. And I just did a Google search on calculating the area of a regular pentagon, and I found this calculator soup, which is something I use a lot. So I've got a regular pentagon, and the side was 4.5 feet, so it automatically calculates the area for you. So that gives 34.84. Okay, so I thought that was kind of a good thing to show you all. You know, when you do your homework, my God, don't go and just do stuff like this. The point is to learn the mathematics, but, you know, check and verify stuff. I try to be big into helping students to realize that they have the ability to do that, so take the time to do that. All right, so I just wanted to correct that. If you're done, just a minute, I'm going to pause, work out the problems, and then you can check your answer. Okay, so let's go ahead and check and see how you did. The first one is just straightforward Hurons formula. So you need to check calculations. I got 352.7 square units. So first thing to do is to do the semi-perimeter, add up the sides, divide by 2. You would get 54 for your semi-perimeter as your first step. Then to use Hurons formula, 54 minus 22, 54 minus 50, 54 minus 36. I went ahead and just calculated it kind of like this, and ultimately I did the square root of 124,416. That gives the answer. Okay, so that's how you would do that. That's a very straightforward Hurons formula problem. Okay, pause if you need to pause, otherwise I'm going to the next page. Okay, this page, what I did, and you may not have done it the same way I did. So I got 259.6 square inches, and I decided to do it this way. Well, I already gave you the angle, but what happens is, what I was trying to show you previously, like if you have, it kind of goes like this, the number of sides, and you want to think about this. If you have a triangle, then that adds up to 180 degrees. If you have a four-sided figure, it adds up to 360. A pentagon, 5 sides adds up to 540. 6 sides adds up to 720. These things just keep going up by 180 as you add a side. So if you add a side to a polygon, the angles add up to 180 degrees more because you can break it down into another triangle. Okay, so I divided that by 6 to get 120 degrees, and then I decided to do it this way. And I didn't ever use Hurons formula. I just broke it up into these two triangles. So I looked at this triangle is easy to do. I can use the side angle side formula. And then I got a square. Okay, I can find the area of a square. Now you could break that up into two triangles if you wanted to. There's just no need to do that, I don't think. So this is how I did this. So by using the side angle side formula, I do 1/2 of the product of the sides, 10 times 10, and the sine of the angle in between. So when I did that calculation, you can see how I did this on the calculator. I got 43.3 square inches. So that's what the area of those two triangles is. Then what I elected to do was just call this side x, and then I can use law of cosines. So I can say x squared equals 10 squared plus 10 squared minus twice the product of 10 times 10 times the cosine of the angle in between those. So you can see how I did this calculation. I ended up ultimately doing the square root of 300. That gave me 17.3. All right. So what that gives now is you have a rectangle, and this rectangle has a height of 10, and it now has a base of 17.3. So the area of the rectangle is base times height, so it's 17.3 times 10, so it's 173 square inches. Then I just add all these sides up, so I got 259 square inches. That's one way to do it. There's other ways to do this as well, and you may have come up with a different way to do this. I could think of many different ways to probably put this thing together. You might even be able to find the area of this triangle right here and multiply it by 6. You have two trapezoids. If you know the trapezoid area formula, you could get the area of this trapezoid and double it. It's all kinds of ways. The other thing I did is I just went to that website I showed you. And this Polygon Calculator is a good way to check your answers to a lot of different things. So it's a 6-sided figure. It's a regular polygon too, 10 inches. So that gave me 259.8. Well, I'm off a little bit, and that's all due to the rounding. But essentially, I get the same answer then. Okay, so there's a quick way to check your answer. So that's one way to do that. If you did it another way and got a valid answer, that's also okay. I think some of the other ways to do this problem, you would probably be forced to know a little bit about geometry, but the idea is you would end up with this. You could have used Hurons formula like this. I think I'm going to go ahead and just show this to you, just in case anybody did this. So like if you look at this inside triangle right there, it turns out that this angle is, these angles get bisected, cut in half. So you would end up having basically a triangle with all of the sides, all the angles would be 60. And then you would have 10 and 10 like that. So you actually could use Hurons formula to do that. So if you did Hurons formula, then you could just do semi-perimeter is 10 plus 10 plus 10 over 2. So that's 30 over 2. So that's 15. Then Hurons formula, you would just do this. You would do 15 times 15 minus 10, 15 minus 10, 15 minus 10. Okay, like that. And then that would end up just giving you 15 times 5 times 5 times 5. Okay, so that would end up being just the square root of 15 times 125. Then I'm going to go ahead and just do that on the calculator here. All right, just in one step. So square root of 15 times 125. And that's going to give this. Okay, so it's 43.3. And then there's 6 of these, so the total area would just be 6 times 43.3. So that sounds like it would give about the same answer. Yeah, that's 259.8. Okay, maybe even a little bit more accurate than mine actually by doing it that way just because of the rounding. I think you'd probably round that to about 0.81. And if you did it that way, you're a little bit more accurate than what I did. Okay, and that's just because there was less rounding involved in that problem. So those are two good ways to do that. The second way, you have to know some facts about geometry. That's why I chose it to do it the way I did. All right, so that'll wrap up this section, and I hope you do very well. Students usually do very well with this material on triangles. It's logical, it's applicable, a little bit less theoretical than what we've been doing. So have fun as you work out and learn problems. Don't forget this site that'll check answers too. Don't do your homework that way, for Christ's sakes, but use it as a way to check. All right, good luck.